College exam entrance exam company has determined that a score of 20 on the mathematics portion of the exam suggests that a student is ready for college level mathematics. To achieve this goal, the company recommends that the students take a core curriculum of math courses in high school. Suppose a simple random sample of 200 students who completed this core set of courses results in a mean math score of 20.3 on the college entrance exam with a standard deviation of 3.4. So that 20.3 is a little bit above 20, relatively speaking. Is that a big increase? We don't know until we take into account the sample size and the standard deviation of the sample. Does it suggest that those who complete the core curriculum are ready for college level mathematics? That is, are they scoring above 20 on the math portion of the exam? So the null hypothesis, when we're talking about the parameter regarding population mean, is always about mu. The null hypothesis always has equal and innocent until proven guilty, which would mean here that overall the population is 20, and we have this subpopulation taking the core curriculum, still about mu, strictly greater than, and comparing against the same number, 20. Students were randomly sampled. The sample size is 200, so yes, that's larger than 30. We are not specifically told that the students' test scores were independent of one another, nor do we know anything about the population size, but you probably have millions of students each year taking these tests. So 5% of even 1 million would be 50,000. And we only have 200 in the sample. So if I'm right that millions per year would be taking the test, and independent of one another, we can check that the sample size is less than or equal to 5% of the population size. If that population really is in the millions, then we probably have that as well. Use the classical approach. Okay, so first of all, same formula. By the way, in that previous example, notice that I put parentheses around the subtraction in the numerator and around the mini fraction in the denominator. So we had an X bar of 20.3, and we're going to subtract from that the claimed mean of 20. Then divide by the sample standard deviation of 3.4, and divide that within that overall division, divide the standard deviation by the square root of the sample size, 200. They want this rounded to 2 decimal places. So that's going to round to 1.25. This is a one-sided test, a right-tailed test. So the critical value, since we're using 0.05, since it's already one direction, we do not need to divide alpha by 2. We just take the 0.05 in the one-tailed test. and going down to 200. 0.05. There is no 200 degrees of, sorry, the sample size is 200, so there are 199 degrees of freedom. That's not shown. Notice that that would be in between 100 and 1000. The score for 100 is larger than the score for 1000. In fact, as you work your way up any of those columns, the critical t-values for smaller sample sizes and therefore smaller degrees of freedom are going to be larger because we play it safer. We play it more conservative when we have smaller samples, less information. So I'm going to try the one that's above 1.660. That's going to mean it's going to make it harder to reject the null hypothesis with that larger value. It's going to be harder to reject that innocent until proven guilty because of that sample size, and we're missing some information. Okay, so our t-value was 1.25 versus a critical t-value of 1.660. Well, check this out. So that critical score of 1.660 cuts off an area of the top 0.05 or the top 5%. Remember, this was just a one-sided or one-tailed test, a right-tailed test. 1.25 does not get into that critical region. And so that means that that t-score, 1.25, was not something extreme, not something unusual. That went back to X bar, not being unusual. So if mu really is 20, this is not all that unusual a result after taking the core classes. So what do we conclude? Darn it. Okay, apparently that did not record. So it gave me a different version of the question now. What I wound up doing, because that was not in the critical region, my answer, which turned out to be correct, was that we do not reject the null hypothesis. We failed to reject the null hypothesis. Therefore, there is not sufficient evidence to conclude that when students that take the core curriculum take the college entrance exam, they are not scoring greater than the 20.